Hi, my name is Dhruv. I had been the chief knowledge expert of institutes like Time and IMS and have mentored students for CAT and Z for the last 22 years. I have recently started a venture called Academic, wherein I help the students who will be writing for Indian domestic entrance exams like CAT, ZAT, etc. And obviously, exams which can take you abroad like GRE, GMAT, SAT, and so on. Today's session, I'll be demonstrating to you how the quantitative reasoning or the quantitative aptitude part of these exams is different from the maths knowledge that you have done in your schools and colleges. We'll start with an example. So today's session is about how is quant different from maths. Let's understand it by understanding it is not about what you do. It is also about how you do it. What it fundamentally means is that when you are solving quant questions, it is not only about getting an answer, it is also about getting the answer in the most efficient way because you will be fighting against time. And here, the concepts have no alternative. You will need to know the concepts. Only when you know certain amount of concepts, then only you will be able to apply some shortcuts and etc. And that is where your marks in terms of absolute marks will increase. Okay, CAT does not give any marks for your process or method. So even if you don't follow the traditional Puritan way of solving the question, it does not really matter. You can still get an answer. Okay, and therefore the strategies that we are going to apply, some of the strategies that we are going to apply for solving CAT questions will include plugging in the options to get an answer, guessing the answer, trying to solve the question backwards. That means going from options, we go towards the solution. And sometimes even visualization helps. Let's try to see some of the questions that came in previous year's papers, and then we can see how we can solve these questions without really getting into the longish process of doing it. Okay. Now, this is one question that had come in the paper around 5 years back in one of the business school entrance exams. How do I solve this question? Now, one way of solving this question is obviously the long method, which will mean that I would have actually solved it by taking the LCM, making it, for example, I would have made it practically, uh, first of all, finding out what is this value. So I would have made it as 40, then I would have made it as K plus 2K, then I would have made it as 3K by 40. Okay. And then finding out what percent of 2K is. So I'll have got 3K by 40 in the denominator, 2K in the numerator, and then multiplying it by 100, canceling it out and getting me the answer. Now, the thing is, you don't really need to do that. Okay. The easiest possible way of doing this question is to set a value of K, which will help me to make my life easy. For example, you can see that the denominator in this is actually 40 and 20. So if I take a number which is divisible by both 40 and 20, this number will look very, very easy. For example, let's assume that K is actually equal to 40, in which case this value becomes 1, this value becomes 2. So therefore, this value becomes 3. Okay. And this value, which is 2K, will become 80. They're asking what percent of 2K is this value. So we are talking about practically a value of 3 by 80. Okay. Now, for anybody who knows the values and percentages as 1/4 as 25%, and therefore 1/8 would have been 12.5%. Okay. 1 by 80th would have been 1.25%. And therefore 3 by 80th would have been 3.75%. So therefore, practically now everything can be done mentally, because the only thing that we need to do is assume Maniman that K is equal to 40, which means this is equal to 3, this is equal to 80, we need to do 3 by 80. 1 by 8 is 12.5. 1 by 80 is 1.25. And therefore, 3 by 80 would have been 3.75. Okay. So the question, which practically used to require approximately 10 to 12 minutes, or sorry, the question which would have required approximately 2 to 3 minutes could have been solved in less than 40 seconds. Let's look at this question. Okay. It says a jug is 1/3 full of water and jug B is half full of water. The capacity of jug B is thrice the capacity of jug A. Okay. If the water from jug A is poured into jug B till jug A is emptied, what fraction of the capacity of jug B is still empty? Okay. Now, similar, absolutely same type of a question, wherein we are fundamentally talking about dealing with lot of fractions. Now, one way of looking into it would have been saying that the capacity of jug A is 3x, the capacity of jug A is x, then putting lot of x, 1/3 x, half 3x, and so on and so forth. And you would have finally got the answer in terms of fractions. We don't really need to do that. Again, let's focus on the concept that capacity of jug B is thrice the capacity of jug A, which means jug B will have 3 times capacity of jug A. And we also note that we are dealing with figures like 1/3 and half. So if we can take a number which is divisible by both 3 and 2, that would have made our life easy. Okay. So the simplest possible thing to do is to take the capacity of jug A to be, let's say, approximately 6 liters. Okay. Now, why I take 6 liters is because it will be divisible by both 2 and 3. So even if I want to deal with numbers like 1/3 and half, it would have made my life easy. So now let's take the capacity of jug A to be 6 and capacity of jug B to be 18, because the capacity of jug B is thrice the capacity of jug A. So jug A is 6 liters, jug B is 18 liters. It says jug A is 1/3 full. That means we have 2 liters here. Jug B is half full. That means we have 9 liters here. Okay, even if the capacity is 18 liters, minded. Now, if the water from jug A is poured into the jug B till jug A is emptied, that means now this whole 2 liters would have come here. So jug B would have got 11 liters inside it. And its total capacity, if you remember, was 18 liters. Out of that, 11 liters are filled. They're asking how much of capacity of jug B is empty. That would have been 7 liters out of 18 liters. And therefore, this is my answer. I don't have to deal with fractions. I just have to deal with some beautiful numbers, and you should be able to get your answers. Again, one question which looks difficult. And therefore, if I go keep on doing it 1 by half, then making it 3 by 2, then reversing it, then doing it, and so on, it would have made your life difficult because it would have taken you at least 2 minutes. However, in this question, we can take help of the options and make some values which will make this question look super easy. Now, let's look into it. All I can tell you is this number looks 1 plus something. We'll look into that something later, but definitely it looks at 1 plus something. And therefore, it is definitely going to be greater than 1. Okay. Now, therefore, it automatically means that this answer, and this answer is gone, because each of these answers are either 1 or less than 1. Whereas my answer is definitely greater than 1. Now, we have got 2 options which are greater than 1. Okay. Now, let's look at the bracket part, which we did not consider it till now. It is 1 divided by 1 plus something, which means the denominator is bigger. The denominator is greater than 1, which will mean that this portion or this number will be definitely less than 1, which means the total sum of this value will be definitely less than 2. Whereas if you look at option 5, it is definitely greater than 2. And therefore, the only option possible in this is 8 by 5. If you understand and guesstimate this answer, you will be automatically be able to say that this question can be solved in less than 40 seconds. Let's look at question number 4. Let's read it out. It says trains A and B travel between Washington DC and Philadelphia at their constant speeds. Train A travels at 80 miles per hour, B at 60 miles per hour. Both trains start at the same time from Washington DC. Train A arrives at Philadelphia 40 minutes earlier than train B. What is the distance in miles between Washington DC and Philadelphia? Okay, so two trains, one train travels at 80 miles per hour, another train travels at 60 miles per hour. Both of them start at the same time, but obviously train A takes 40 minutes lesser than train B because it is very clearly traveling at a higher speed. They are asking for the distance. Now, again, going by the traditional way of doing, I would have taken my distance as D, then D by 80 and D by 60. The difference between these times would have been 40 minutes, which is by hour. Please remember they're all miles per hour, so you have to keep the unit constant. The difference between the two would have been 40 by 60. Remember, this would have taken more time because it is slower. So D by 60 divided D by 60 minus D by 80 would have been 40 by 60, and you would have got the answer. I actually don't need to do that. Okay. What I can do is whenever you have at least 5 options or any value that you can take, I can simply do back solving. For example, if I take 120 as my answer, if 120 is my answer, then traveling at 60 miles per hour, I would have taken 2 hours. And traveling at 80 miles per hour, I would have taken 1.5 hours, right? If you understand that, because 120 divided by 80, if you cancel it out, it is 3 by 2 hours, so 90 minutes. Therefore, the difference is 30 minutes. Okay, wherein I actually need 40 minutes. And therefore, the distance cannot be lesser than 120. The distance has to be greater than 120. So if at all I had to move, I will move towards 160 and not towards 100 or 80. Now let's look into 160. If the distance is 160 and if it is traveling at 80 miles per hour, it would have taken 2 hours. And if you travel at 60 miles per hour, okay, do the fractions inside your brain. It is going to take 160 divided by 60, okay, which will mean that 1 hour, and then we will be left with 40 by 60, which is 2/3 of an hour, and 2/3 of an hour means 40 minutes. Okay, so 2 hours and 2 hours 40 minutes, okay, which means the difference is 40 minutes, and therefore 160 must be the answer. Again, I don't need to make an equation. I don't need to make anything. I simply have to plug in with the options or back solving, and you should be able to get an answer. This is one of my favorite questions because it actually looks very, very tough. This is one question which came as a geometry question, and a lot of people actually tried to apply geometry saying, half base into height, triangle, ratio to width of the stair is 3:2, and so on and so forth. Okay, it says a staircase has 6 stairs of equal height and equal width. Okay, so height and the width are given. Ratio of width to height for one stair is 3:2. What is the ratio of the area of the shaded region to the ratio of the area of the complete cross-sectional area of the staircase? So fundamentally, they are asking for the ratio of the shaded region, this one, summation of these regions, okay, with respect to the complete cross-sectional area. Now, one way of doing into it is actually making the diagram saying that, okay, equal height and equal width. So I can find out how much is the width, how much is the height. Ratio of width to height for a stair is 3:2. So we'll calculate that, take it as 3x, take it as 2x, okay, and then find out the answer, okay. Mind it, while I do that, a simple visualization would have helped that this is what it looks like. Okay. Similarly, if I add these two, I'd have got 2. If I would have added here, I would have got 3 stairs. Okay. If I would have added here, I would have got 4 stairs. Okay. So here, this is 1 stair, 2, 3, 4, 5, and 6. So therefore, the total cross-sectional area is practically that of 6 bricks. Okay, 1 plus 2 plus 3 plus 4 plus 5 plus 6. So 6 for 10, 15, 21. Okay, and out of that, we are talking about 1, 2, 3, 4, 5, 6. So practically 6 half bricks are equivalent to 3 bricks. So therefore 3 by 21, 1 by 7 becomes my answer. Okay. Now, what I am trying to show out here is when you are solving these questions, you need not solve it by the traditional way because CAT or GMAT or GRE is not really checking your knowledge of how to solve the question. If you know your basics well, and if you know it slow and steady, you can apply those concepts to do these questions smartly, which can be solved, therefore, in very, very less time. Okay. If you don't learn it that way, then scoring higher in CAT, and when I mean higher, I mean your best, because please remember, you will never know how much others are scoring during the paper, and therefore you have to achieve your best. This can be achieved only when you can concentrate on how equally as what. For more such tricks and tips, I have started this online capsule course on CAT. This will have Quant and LRDI workshops, verbal workshops, lot of study material, and free videos to revise. Also, if you actually get a call from a good institute, the full GDPI module will be absolutely free of cost. This is what you have in the course. 5 Quant workshops covering most important concepts with examples and notes. 5 LRDI workshops with shortcut techniques and strategies. 5 VARC workshops covering all the fundamentals and strategies. 1 non-CAT LRDI workshop covering NMAT and SNAP as well. 2 decision-making workshops for ZAT. Full Quant LRDI and VARC theory book in PDF format, which you can refer to. 50 plus sectional tests, and as I said, the complete GDPI preparation once you get a call. This comes at a course of just 7,500 only. You can, however, get special referral discount for groups of 4 or more people, and the prices will come down much lower. Hope to see you soon. Get in touch with the numbers or the email ID mentioned here for more details. Thank you.